Alrighty. Well, first of all, thank you all for coming out to the Intro to Machine Learning workshop. I know that this workshop has been promised since like the beginning of the semester, so I'm very excited to finally give it today. Yeah. Okay. Before I start, I'm just gonna quickly. Yeah, go ahead. Yes, I am recording. Awesome. I just the one. But thank you for confirming. That's important. Just quick introduction. I'm Joanne Wang. I'm a third-year computer science student, and I've done machine learning a lot just in research context. So I do have some experience working with scikit-learn and Python. So I'm going to share with you that information today. So this session is going to be like what I like to call a baby machine learning session. It is very, very basic, very beginner friendly. The reason why we're going so simple is so that you have a sturdy foundation to build your knowledge off of, and in the future you can explore a lot more features. And so yeah, don't feel intimidated by this session. If you ever have questions, just raise your hand and I'll stop and answer it. All right, so let's get going by first addressing what is machine learning in the first place. So in this photo we see apples and oranges. And my question to you is, if you were to ask a machine how to identify apples from oranges, what are some criteria you would tell it to look for?
Color.
Yes, color, okay. Any other ideas? Kat? The shape, okay. AJ?
Apples usually have the stem.
Mm-hmm, that's a good point. Other ideas? Yeah.
Oranges are always orange.
That is true. Yeah, so these are some great criteria. I would like to point out that some of the things we said, such as color, you said that if it's orange, then chances are it is in orange. But the question comes up: what about yellow apples? Because in certain lighting conditions, they might look orange, and so the machine might confuse it for an orange when it's an apple. And we also said shape, but as you can see here in the photo from this angle, all of them are circles. So that can also be difficult for the machine to classify. So this is just a very brief example of how classifying things are not as straightforward as you might think. But machine learning is able to make these differentiations by learning. And the way that a machine learns is that when you give it a lot of data, it'll look for different patterns in that data, and then from there, it will make accurate predictions, and it will keep doing that until the accuracy of the predictions hits a certain threshold, like 90%. And whenever you're happy with how accurate it is, that's when you have a fully functional machine learning model. Okay, so any questions thus far? Okay. So like I said, machine learning is basically the process of taking data, teaching the machine to learn patterns, and making predictions from that. So why are we even doing machine learning in the first place? Like, why is it important? So when you have accurate predictions, depending on the data and what you are using it for, it can be very crucial to the success of like a company, or if you are doing research, that would be very important. For example, one of the most classic examples is if you had a ton of MRI images and you were trying to identify whether a patient had cancer based on the shape of the tumor. If you are able to train a very accurate machine learning model, not only would you be able to make predictions more accurately, you would be able to do it more quickly. And that can end up saving people's lives, as well as increasing the credibility of the hospital or research group who is creating this model. So that is one example of just the importance of machine learning in the long run. So when it comes to the practical pipeline, I've boiled it down to these 5 steps. You take the original data, and if you think about what data looks like, it's typically in a table, and so they're often decimal values, sometimes they're string values, and sometimes you even have missing data values. So in those cases, the machine is going to get confused if you feed that data through it immediately. So what we want to do first is go through pre-processing, and what that means is if you have like an empty cell in the column, then maybe you would fill that in with 0, or maybe you would fill that in with not applicable. So you would look at the different holes in the data and try to patch them up. so that the machine will not be confused when it's trying to learn patterns. So another way that you could pre-process the data is if you had, like I said, string values. The machine might not be able to look at a word like the word dog or the word cat and know what it means. So instead, you might want to transform that to binary values of zeros or ones. And by doing so, you're teaching the machine how to interpret the data before you actually feed it in. So once you do that, you do want to take the data and split it up. So has anyone here heard of what a training and testing split is? Yeah.
Yeah, so I'm in algorithms for machine learning.
Mhm.
I've heard of this.
Mhm.
I don't really know what it is.
Okay.
Probably should know what it is.
Yeah. Any guesses? Okay.
You make a testing model and then you make a training model. I mean, you make a training model and then you make an accurate model.
That is, it's close to that, but it is a little bit different, and so I would be happy to explain the difference. So when you start out with data, imagine if we gave a model all of the data at once, and we were saying, hey, here are like 100 pictures of cats and dogs, and here are 100 labels corresponding to whether it is a cat or whether it's a dog. So if you give all of that information to the model, then it might not actually learn the patterns. It might simply memorize, like, oh, this picture is a cat, this picture is a dog. So when you give it a brand new image that it's never seen before, it might get it wrong because it's not in the 100 that it memorized. So that's why it's so important to take the data and split it up into two categories, training and testing, and sometimes even a third one called validation. So maybe I would give the model 80 pictures of the cats and dogs from before, and then it will learn the patterns of, okay, so cats have pointy ears, dogs, depending on the breed, may or may not, and so look for all the differences. And then the 20 at the end are used to evaluate how well the model performs on brand new data that it's never seen before. So again, because these 20, the remaining 20, we did not teach it by giving it them in the first place, it's not going to memorize it, and so we can use those 20 to evaluate how accurate the model really is. So does that make sense? Okay, any questions? Like, feel free to answer, because this is a beginner session, so no question is stupid. Okay, so from there on, like I mentioned, we plug it into the model, and there are many different types of machine learning models. So for now, we're not going to delve into the specific differences of each model because they operate on many different algorithms, and when you're practically doing machine learning, you often don't even need to know how the model works. Sometimes it does work like a black box. You just feed the data in, it does its thing, it gives you the output, and if all you're doing is getting a result, and then that's perfectly fine. You don't even need to understand the specifics unless you really want to. And then finally, you will evaluate how accurate that model is. So like I mentioned before with the 80 cats and dogs versus the 20, maybe 18 out of the 20 were classified correctly. In that case, you would do the math and you would figure out that it is 90% accurate. And if you're comfortable with the accuracy of that model, then you would move on and use that model for whatever you're trying to do in the future, such as classify 1,000 cats and dogs. And if you're not happy with it, then you can refine the model by tuning hyperparameters or tweaking things in this pipeline to get it to be even more accurate. All right, so that's like the bird's eye view of machine learning. Do we have any questions so far? Okay, sounds good. All right, so as another step of being a broad overview, there are 3 types of machine learning. So there is supervised data, unsupervised, and reinforcement learning. So in supervised machine learning, we start out with data that is labeled. So like I mentioned before, if you have the images of the cats and dogs, the labels would be whether each image is a cat or a dog. In these situations, we know the right answer, so the machine simply needs to figure out how to accurately predict the label each time. Unsupervised machine learning is when we deal with data that is not labeled. So that might mean we have no idea what the data is, but we still want the machine to find patterns for us. So what the machine will do instead is it will group data together based on their similarities. And then finally, reinforcement machine learning is when an AI learns from consequences. So if you punish the AI, then it will avoid that action in the future, and if you reward it, it will seek to do it more frequently. So here is a visual of supervised versus unsupervised learning. So you see supervised learning, we know the labels for each of the data points. We see the red circles, the blue X's, and the green stars. So all we are doing is we are trying to get the model to draw those 3 lines in such a way that it can separate the data clearly. That way, if we had like a brand new data point that was, say, here, then the model would say that it is a red circle. Whether or not it actually is, we will find out later depending on how accurate the model is. And then unsupervised learning is here. So this is when we do not know what the type is, but it is noticing that there are 3 clusters of data that are close together, and so when a human looks at this, the findings of the model, then maybe they will be able to figure out, okay, this group represents this group represents that, and the use of machine learning is that it can often find patterns that we as humans cannot see because of the sheer amount of data or because the patterns are so hidden away. So this is a very simple example of what supervised and unsupervised learning are. And then here, this is reinforcement learning. I really wanted to include this video because I thought it was very funny. So I'm going to play like a little clip of this. So this is a very long video. If you think it's interesting, definitely check it out. But basically, they put the AI Albert through multiple different rooms to try to teach it how to walk like a human. And this is an example of reinforcement learning because whenever it's doing something that they're not happy with, like doing the worm, they end up punishing Albert until it starts to learn how to walk on its feet. And when his 2 feet are touching the ground, then they reward him. And slowly over a painstakingly long process of going over and over again, the AI succeeds in learning how to walk like human. So that is a very short example of what reinforcement learning is like. But for the purposes of today, we will be dealing only with supervised learning in which we have label data, because this is just to teach you how to make a very basic machine learning model. So on your own time, you're able to develop it further and improve it for whatever you are trying to learn and predict. Okay, so today the 2 technologies we'll mainly be dealing with are scikit-learn and Python. So how many of you here know Python already? Okay, so good number of you. If you don't already know Python, do not worry. In my opinion, it is the most simple language to learn because it is very much like English or pseudocode. So I wouldn't worry too much about not knowing Python. It's very easy to pick up. You could like pick it up in less than an hour, I would say. Scikit-learn is a library that is that works seamlessly with Python. And what scikit-learn does is that it has a lot of machine learning algorithms already, so you do not need to design your own model. They are already made for you. All you have to do is import them from this library. And scikit-learn will also help you in the pre-processing steps as well, making the train test splits, and they also have metrics for evaluating how well your model performs at the end. So we'll get to see the functionalities of scikit-learn more today when we do the demo, but the sheer amount that this library can do is too much to cover today, so I highly recommend you check it out if it interests you. Okay, so when we're doing machine learning, what even is the environment that we do it in? So typically when we're coding, we just use an IDE, and that might look like Visual Studio Code. I know some maniacs use Notepad, but I wouldn't recommend it, but people do that and it works. So the environment when it comes to machine learning are called Jupyter notebooks. And so these are files that end with .ipynb, and that just basically is Jupyter Notebook compressed. And you can either install Jupyter Notebook directly into VS Code, which is what I do, or you can access it online via sites like Google Colab or even Kaggle. And another thing that Kaggle provides is pre-collected data sets. So if you just wanted to learn how to do machine learning and you don't want to go through the trouble of collecting a data set, or you don't have specific data that you're trying to work through, then I recommend practicing with this site because it has everything you need. So that's actually what we will be doing today, is that we will be going out to Kaggle and we'll be walking through a very simple experiment just so you get an idea of how machine learning works. Okay, so any questions so far before we dive into it? Because I want you to be comfortable with the conceptual things I just covered. And remember, no question is dumb because this is a beginner session. Yes?
Does machine learning involve like data?
Yes, exactly. Mm-hmm. So that's the pre-processing step, and that is when you clean it up, like if you have missing values, you patch that, or if you have the formats wrong, then you would convert them to a format that it recognizes. So sometimes that's manual, sometimes that can be automated. All right, any other questions?
Is it okay that you could demonstrate how that is like done?
Let me think of the best way I could demonstrate that. So give me I think the data set we'll be working with today is pretty clean already, but I'll point it out. I'll have you use your imagination, so I'll point out how you would clean it up if it were not already clean. So hopefully that would help. And then if you have questions later after we're done, just ask. Okay. Anything else before we get started? Okay. So what I'm going to have you do is, if you would like to follow along, please go to Kaggle. So that's just kaggle.com, and then just log in with Google or something, and then create a new notebook, and I will be walking you through the whole process. So I will give you like a minute to do that, and then I will get started. All right, I'm going to walk through it on my screen here, and you can either follow along or just look, and I'll explain all the steps that I'm going through. If you have questions, feel free to interject at any time. I want you to feel comfortable asking anything. If something confuses you, just go ahead and ask. So the first step is you're going to see the home screen. So what we're going to do is we're going to create a notebook. So this is like the Jupyter notebook that I mentioned before. I'm just going to title this Intro to Machine Learning Demo. And you'll notice that this is, okay, so I think something you should know about Jupyter Notebooks is that the whole reason why people like to use them is you can run chunks of code instead of just having run from top to bottom in the entire screen. And you can include markdown cells, which means you can just write text and make your comments look nice. So you get to run things in different orders and run a few chunks at a time, or selectively pick which chunks you want to run. So we see here that you're automatically given this first chunk of code, and if we press play, what it's doing is it is running it, and it will import a couple of libraries for you. One of them is NumPy, so that is a library used to do linear algebra, and NumPy actually NumPy and pandas often go hand in hand with scikit-learn because you're learning how to pre-process the data, like I mentioned before, and format everything in a good way. And what pandas does is that this typically handles looking at data frames. So data frames is just a fancy way of saying table. Yeah.
Is it possible you can use Excel spreadsheets?
Yes. Yes. I'm glad you brought that up because pandas, like I said, it can look at tables, it can look at CSV files, and it can look at Excel spreadsheets because that is actually a built-in function.
So how do we know which, like, is there like a case where that data format's better to use on the other formats?
In my opinion, I like CSV more because because Excel is not just for storing data, like you can make the text colored, you can like add different functions. Sometimes that adds another layer of complexity. So if you want to make sure that the data is clear and simple, I would use CSVs, which are comma separated values. Pretty much you would have a function that says read CSV in pandas, and you would use that if you have a CSV, or you can use read Excel, and that would be how you read in that file. So I'll show you how to read in a CSV later, but same logic applies for Excel. So that's a good question. And then so to continue on here, it will also import OS, and this library basically handles like file hierarchies. So if you're trying to access different files that are in different folders, you would use this library. So if you're following along, make sure you hit the play button just so the Jupyter Notebook knows that you've imported these libraries already. So what I'm going to do is I'm going to import scikit-learn. So that's as simple as just write import sklearn, and then I can click play there. Now all of the models, all of the pre-processing techniques, all of the evaluation metrics that are included in this library are now imported into the Jupyter Notebook. Yeah, absolutely. You know, the thing about like standing up here and presenting is I suddenly understand why our professors never zoom in for us. It's because like they don't know it's an issue. And in classes of like 200, everyone's too scared to say anything, so thank you for saying that. Okay, so now you're going to import scikit-learn, simple enough. And then what we're going to do is we're going to add some data to look at. So I found this zoo animal classification data set that I really like. Let's take a look. So this data set pretty much has a table of data where you can basically find out what category an animal belongs in depending on their features. So if we take a look here, this is the raw data file. And we have a couple of different columns. We have the animal's name, we have whether they have hair or not, these are Boolean values, whether they have feathers, eggs, etc. And so if you keep scrolling here, you'll see that, you'll see all of these features, and then at the very end here, the last column, this is class type. So this is actually the variable that we are trying to predict. And it's important to make this distinction because what I'm saying is that this column is the label and all of the other columns are the data. So when we're feeding it into the model, we have to tell them, hey, don't treat the last column as part of the data because this is the label that helps you know whether you are correct or not. Yeah.
Is it always a last column?
Not necessarily. Just in this case, class type is the prediction column because you as the machine learning engineer, you would be deciding which column is the one that you're trying to predict. But typically, conventionally, yeah, people tag it at the end. Most likely at the end, but in their documentation, they should say which one is the label. Yeah, that's a good question. Yeah.
Is Kaggle the website that people go to upload like the data sets?
I would say it is a very popular open source dataset repository, but it is certainly not the only one. Actually, for my senior design project, our team used Mimic 3 data, and that is a clinical dataset. We did not get it from Kaggle. We got it from, I think, a site hosted by MIT. So there are a lot of open source datasets available. You just have to look online and see which one has the dataset you're looking for. And then if you're doing research or if you're doing something for your company, then obviously you would be handed a private data set that is not online. So, yeah. Okay, so this is basically what that data looks like. So let's include that data into our notebooks. I'm going to press the plus button, give it a second. So what it's doing now is it is downloading it. And then, so you can see here, that's the data set. And this is zoo.csv. Okay. Nope, not that one. Nope, oh, should not have removed it. Give me 1 second. Yeah, okay.
How do you do this in Notepad? That's a good question.
Yeah, exactly. You can't do this in Notepad. My point exactly is that's why you need Jupyter Notebooks to do machine learning.
You gotta be an expert to like not make any typos.
I feel like that's true of anything, but I don't think actually. No, I take it back. It is possible to do it in Notepad. It is, because if you treat the whole machine learning pipeline like one giant chunk of code, then it is possible, but I highly recommend against it. So let's see.
You're all stressed.
Hmm?
You're like stressed out.
Yeah, so that would be bad. Okay, let me see. Okay, so I ran this chunk again, and this text at the bottom shows me that I now have access to class.csv and zoo.csv. So the data set that we're going to look at now is zoo.csv, which is the table that I just showed you. So this is how you read in the data into a data frame. And again, fancy name for table, but this is how you put it into a variable. So we're going to set a variable called data, and we're going to use the pandas library, which handles reading data in for us, .read underscore CSV. And like I said before, you would just say read Excel if you had an Excel sheet. And then I would put in the file path to that CSV. Here we go.
And for a table, would it just be read table?
That's a great question. Typically, tables are stored in either CSV or Excel, so I don't know if they have a built-in function for that. But typically, it's saved as a file. That's why you need the file path. And then we are going to type something called data.head, and all this does is it displays the first couple of rows just so you can see what the data looks like. So let me run this. So yeah, now you can see the first 5 rows from this data set. And at the end here you see class type, which again is the prediction variable. So this is how you can like confirm that it got the data in correctly and everything is smooth sailing. Alright, so now that we have the data, that's step 1 in the pipeline that I mentioned before. Now let's pre-process it. So here is another reason why I like Jupyter Notebooks is if I click the markdown button, then I can say pre-process the data. And then the amount of like hashes I set before it specifies how big the font is going to be. So if I tap away from that, then you can see this becomes a header. And if I remove that, then it becomes bigger. This is just the markdown language, but I like it because it keeps my notebook looking very clean. Yeah, so let's pre-process this data, and what I mean by that is firstly we have to again tell the model what the data is and what the label is. So let's tell it that the input data, we're going to call it all x. And the reason why it's x is because this goes back to linear algebra, so we're going to take this for granted for now. So we're going to look at the data and then type in ILOC bracket colon 1 to 17. So what I just typed here is I'm telling the model to look at, well not the model, I'm just specifying that, okay, we have this table that's stored in data, and then ILOC is basically saying index location. So ILOC is saying we want to look at every single row, and that's specified by using this colon here, and only columns 1 through 17. In this syntax, the 1 is included, but the 17 is excluded. So the first through 16 column will be stored here in this variable all x. So now we want to tell it what the label is, which we'll call all y. And very similarly, we say data.iloc every row and 17. So again, this is inclusive, which means look at the 17th column, which as we know is class type, and we're saying that this is the label. So that's how you specify it. So I'm going to run that just so the notebook is aware of this variable's existence. And then one other step to pre-processing the data is we need to do the training and testing split. So like I mentioned before with the example of cats and dogs, we don't want to give it all 100. We're going to give it 80 and then test it later with a 20. So the good thing is scikit-learn handles this for you, so I'm going to import that feature from scikit-learn. So I will type from sklearn.model selection import train test split. Alright, and this is very simple. This is going to be just one line of code. So we're going to say xtrain, xtest, ytrain, and ytest. So these are 4 variables equals train test split, which is imported, and then we give it all x and all y. So what this is doing is that we are feeding in the input data in x and also the labels in y, plugging it into this built-in function, and it will return the 4 variables for us. So that's one. So now we can't see whether it succeeded or not. So what we're going to do is we're going to print out the shape of these variables to confirm that it went through correctly. So let's do xtrain, actually. Copy this. And I'm going to print out the shape of the data for each variable. Right, so that's that. So now you can see that what these numbers represent are the dimensions of the data. So if you look at xtrain, this is saying there are 75 rows and there are 16 columns, just like this test, right? And xtest has 26 rows and 16 columns. So basically what the train test did was that it automatically had a ratio of, I believe, 75% in this case. So that's why it gave it 75 to look at for now, and we're setting aside 26 because there were originally 101 rows. And when we're looking at ytrain and ytest, this is saying we have 75 rows, and the reason why it doesn't say one column is because we're storing it as a 1D array instead of a 2D array. So that's why there's only one dimension. But the lack of a number here just indicates that there is only one column, and this is looking at the class labels column like I mentioned before. So do we have any questions about this?
Is it possible to print like what it's actually stored in like the
Yeah.
dimensions?
So if we wanted to print ytrain, you can see that these are like the indices, and then this is the value for the class type. Yep, and then actually let's print xtrain. So you can see here this is what the data is stored as. You have each of the columns, and these are the corresponding indices.
What are those numbers on the left?
On the left? Oh, those are the indices. So I believe just the way that this data set is stored is that the indices are like scrambled, but ultimately it's not going to matter. You can turn off the scrambling feature, I believe, and sort the data first. But I believe the reason they do that is because when you're making the split, you don't want to, if you're like training the model multiple times, you don't want to give it the same 80 to train each time. If you scramble it, then it'll pick out like a random 80, or no, in this case 75, a random like set of 75 data points for the model to learn on, and then test on the remaining 26, if that makes sense. But yeah, this is what the data looks like. And actually, this is what xtest looks like. Yeah, so it's the same exact format, it's just 26 values here instead of 75. Okay, so that is pretty much all of pre-processing. So the next step in the pipeline is we are going to actually feed this data into the model. So let's specify model. So when it comes to models, you have a variety of options, and the way you can do that is you can look at the scikit-learn documentation. And if you are curious about which models exist, you have classification models, you have regression models, you have clustering models. Basically, in simple terms, classification is when you have like categories you're trying to sort into. Regression is when you have like more numerical problems you're trying to solve, and you're trying to find like a line to represent the trend. And then clustering is kind of like what I said before about unsupervised learning. So in this case, because we're trying to figure out what category the animal is in, this is a classification problem. And so we will use one of the models from here. So you can see these are all of your options for models. You have a very, very extensive library, but today I am going to demonstrate two models for you. One of them is called the support vector machine, and the other is called random forest. So I'm not going to dive into the specific differences of them just because it's a beginner session, but if you have questions about those models later, you can ask me. So for now, we will train a support vector classifier model on this data, and then we can see how well it performs. So to get that model, we're going to import it from the library, and we'll do that by saying from sklearn.svm import svc, and that just stands for support vector classifier. And then we're going to set a variable called CLF, and that just says classifier. CLF equals svc, and this is basically telling it, hey, store this model that does not know what the data is yet, store that into the variable called CLF. Then we will finally introduce the model to the data, and we will do that by using another built-in function called clf.fit. clf.fit, so we would give it the training data as well as the training label. So we give it X and we give it Y. I'm going to hit play here. So you notice that here it's showing me that I now have a trained model SVC. You'll notice that this was very fast. It took like a millisecond. I'm going to give you a disclaimer. This is not always going to be fast at all, especially if you're working with a huge data set. The only reason why this ran in less than a second is because we only have 100 rows. But if you're dealing with a giant data set with thousands of columns, 100,000 rows, it will take a long time. So you will need a machine with high compute power as well as a lot of time on your hands, because one time I ran like a series of experiments for my research, and it took me like a week to get the results back. Yeah, in multiple days. And it just kept running on, and it was in Alienware too, so. But anyways, for this example, this is a very basic model, so it trained very quickly. So yeah, that is, as you can see, this was literally like 2 lines of code. If you combine the two, it would be 1 line of code. And that's why sklearn is such a great library. You don't have to make the model yourself. You just simply import it, you train it, and you're done. So so we basically just trained the model. And our next step is to run some predictions to see how well it performs. So let's do that. Do you have any questions thus far?
You're going to run the prediction on the test data?
Yeah, exactly. So I'm going to just demonstrate an example of just to see like how well the model's performing. Okay, so I'm going to quickly quiz you. I have 2 variables. I have X test and Y test. Which of those variables will tell me what the correct answer is, what the true label is? X or Y? X test or Y test? Yes. Why do you think it's X? Okay.
Why? Because it has like a label.
Exactly. That is a good guess. But X test is simply like the matrix of data to feed into the model. The Y test is the actual label of the correct answer. which we already know.
So the X is used to jump to a conclusion.
Yeah, the X is the input data to the model. That's what it's like learning based off of.
But the X test is like testing like the actual input from it. Like it's an input that's used as a test to determine if it's like good or not.
Yes, exactly. So I'm trying to, let's see how I can explain it better. So when we trained the model, it looked at the patterns in X-train, and it only looked at X-train. And then it figured out some patterns, and then it looked at Y-train to compare its predictions with the actual answer. And if it performed badly, then the model like tried it again, and this all happened behind the scenes in the 1 millisecond that it took for me to hit the run button. That's what it was doing. It was looking at the patterns in X-train, and it was comparing it against Y-train. So at that point, the model felt comfortable enough with how well it was fitted. And then, but like I said, there is a risk of the model just simply memorizing what each like correct answer was, in which case it would be a bad model, because if we threw new data at it, it would not know what to do with it, and thus it would be a bad model, which is why the testing steps comes in. So we take the data from X test, which the model has not seen before. The model is trained at this point, so it has learned the patterns. It's looking at X test, trying to find out, apply the patterns that it identified from its training, and then it compares its prediction to Y test, which is the true label. So does that make more sense? Okay. I think it'll be more apparent once I run this example. But like I said, we have the trained model, and we can make a prediction. We're going to run prediction on X test, and let's just look at like 5 values. So 10 to 15 is saying like, hey, look at rows 10 to 15 in the test data that we're giving you. So when I run this, it's saying that it predicts that for the item at index 10, the label is 1. For the item at index 11, the label is 4, and so on and so forth. And now we can compare what the actual answer was by displaying what Y-test was at those indices. So Y-test from 10 to 15. So we can, let's take a look. So you see, it predicted it was 1 up there, and it was actually 1. But then it predicted the class 4 when it was in reality it was 7. And then it said 1, 1, 1, it's just 1, 1, 3. So we can see that the model did make mistakes. And if we wanted to run like a comprehensive scoring on how well that model performed, we would run clf.score, and then we put X test and Y test in. And this shows you that it's only like 80% accurate, which for our purposes is not good enough. But that explains why like we can get this percentage is basically it's going through each X test and Y test row and comparing whether the label is correct or not. Okay. So does that make sense to everyone? Any questions? Okay, so we've established that this model kind of sucks. Now I'm going to show you why, another reason why I really like scikit-learn is that if you think the model is bad, you change like one line of code and you can do a different model. So let's comment this out. And instead let's use a different model that I really like called random forest. So we're going to say from sklearn .ensemble, we're going to import the random forest classifier. So this is a brand new model, and the algorithm for it is different from SVC, which we just used. So I'm going to say CLF equals random forest classifier. And all I'm going to do, that is it. That's the only code I'm going to change. I'm going to click all the buttons again, and we're going to go through and see how well it performs. So I'm going to click that. It's training. Okay, now we have random forest classifier. Now let's make predictions with the new model. And we see 17112. If we click this here, again 17113. So you can see that this is better. And if we want to see how well it performs, we click the score. We're now up to 92%. So that is a huge jump, and the only thing we changed was that one line of code because we picked a different model. So this is why once you get more experience with machine learning and actually understand what each algorithm is doing, you pick the best model for the scenario, for the data that you are working with. And then from there, you can tweak it even more by changing what we call hyperparameters. And that will modify the algorithm in such a way that it can make even more accurate predictions. And oftentimes the goal of getting accuracy is like at least 97%, but it really depends on what you're trying to do with this data. I'm just teaching you like the most basic framework for whenever you're trying to train a model. My computer's about to die. Okay. And yeah, that's pretty much it. That was very short and very brief, but this is everything you have to do. Once you have the data, you pre-process it, like I showed you, and you plug it into the model, and then you evaluate how well it performed, 92%. And if this is too low for your liking, you just go back up, change the one line of code, use a different model, or do some research into how, like, which one will be the best for the job, and then you're done. So that's it. Like I said, this is baby machine learning because this is like the most simple I could boil it down to. But hopefully you take away from this that machine learning is not as hard as it seems sometimes. I know people get intimidated because it's like a buzzword, but this took less than an hour, and now you know how to do basic machine learning. So if you're interested in learning more in the future, I have some resources, and basically the first link is a link to the documentation. The second one is like an article that you can walk through that's pretty much a tutorial if you want to go through this on your own time. And then the third one is this scikit-learn crash course, which is like a 2-hour-long video. I didn't go through it when I learned it because I didn't need to be that familiar with scikit-learn, but if you're curious, that is there as a resource. And yeah, pretty much just go through YouTube tutorials, look at Kaggle. If you have any other specific questions about doing machine learning, feel free to ask me because I have experience doing it in research contexts and hopefully in industry contexts moving forward. But that is about it. So, we're done. Yes?
How do you use scikit-learn for like any of your research or any like of your projects that you've done?
Mhm.
Machine learning? Like the one, the coding that you were talking about?
Yes.
What type of models did you use for that?
I used the random forest one, just like I used just now. And the reason why we picked that was we researched, so for the clinical project I worked on for senior design, we did some research on what other people had done in similar contexts. And they also use random forest, so we decided that, okay, if it was good enough for them, it's probably good enough for us. So after doing some research, we picked that model, and we used it, and it works great. So yes.
Is it true that machine learning is like more research oriented than like software like development or like data engineering in some way?
Where did you hear that? Because I've never heard that before.
It's a random thought.
Okay.
It's not
Oh, I see. So that, no, I wouldn't say machine learning is more research oriented because a lot of people use machine learning in industry, and it is a branch of software development, I would say. The only reason I emphasize research is because that's my experience with it, but it can be either or. Yeah. Any other questions? If not, later you can like just come up and ask me. But that's pretty much it. I tried to make this short and sweet, and here you are. So there. These will be posted. So we're done.